Hello, in this video we are going to look at solving quadratic equations by factorising. Now quite often we're asked to solve a quadratic equation. It might be for different reasons. It might be so that we can sketch the quadratic equation. It might just be to find the roots or the solutions. Factorising is a really useful method. It works with many quadratics but not all. Let's have a look at some examples. So the first thing we need to do is actually factorise our quadratic equation. So this means that we are going to put the quadratic into double brackets. Now this quadratic has a coefficient of x squared that is 1. So that tells me that in my brackets I'm going to have two x terms, because if we remember when we expand brackets, x times x is going to give us this x squared. Now the two numbers that go in the brackets are found by looking at factors of 3 that add to make -4. So sometimes it can be helpful to list the factors of 3 over to the side in pairs, so you can have a look and see which ones actually add together to make that middle term. So in this case, -1 plus -3 is equal to -4. So these are going to be the brackets. These are going to be the numbers that go into my brackets. Now I'm going to solve. Now what I've got here is a bracket times a bracket equaling 0. Now in order for a calculation to equal 0, one of the numbers being multiplied must be equal to 0. So this means that one of the brackets must be equal to 0. So either x minus 1 is equal to 0 or x minus 3 is equal to 0. So I can solve this by rearranging just like a normal linear equation. I'm going to add 1 to both sides on the first one, and I'm going to add 3 to both sides on the second one. So I've got two solutions for this equation. I can actually check my answer by substituting it back into the original equation, and I would suggest with quadratics it is a good idea to check your solutions, because it's easy to make a mistake and it only takes a minute to check. Let's have a look at another couple of examples. So in B we've got x squared plus 6x plus 9 equals 0. So I'm going to start by popping it into brackets. Once again I've got this x squared, so I know I'm going to have the x and the x in the brackets, and I'm looking for factors of 9 that add to make 6. So I've got a few options. Everything's positive, so that does tell me that both of my factors need to be positive as well, so that's a good indication. So I can see that 3 times 3 is 9 and 3 plus 3 is 6, so I can add those in. Now in this one my brackets are actually the same, so this tells me that I'm actually only going to have one solution to this quadratic. I've just got when x plus 3 is equal to 0, so x must be equal to -3. Again, I could check my answer by substituting it back into the equation. Now the last one looks a bit different. It's still that quadratic, it's still got the squared term in it, but it's actually only got 2 parts to it. So when we come to factorise it, it is going to look a bit different. It's actually only going to have one bracket when we factorise this. And the reason being is it's got a common factor of b. And because it's got this common factor of b, that b is just going to sit on the outside of a single bracket. And then I'm going to have b on the inside. You can see the b times b is going to give me the b squared, and then I need a -2 to give me the -2b at the end. Now I'm still going to set each part equal to 0. It's just that the first part is just b equals 0, and then the second part is the whole bracket. b minus 2 is equal to 0, so b is equal to 2. It's quite easy to forget to factorise and try to divide by b in a situation like this. If you were to divide by b, you would lose one of your solutions, so you wouldn't answer the question fully. So always factorise to make sure you get all of the possible solutions.